As one of the fastest accelerating and most aerodynamic electric trucks in the world, the Tesla Semi continues to be upgraded to achieve an even lower drag coefficient in its new version, preparing for mass production next year. To be honest, the Tesla Semi has been one of the most overlooked vehicles, mainly because very few have been produced despite its debut nearly 9 years ago. There are many reasons behind this, but at last, the mass production line has been completed, and anyone will be able to order a semi-truck next year, not just large logistics companies. The new version of the semi-truck will also cost less, thanks to several adjustments revealed by Dan Priestley, lead engineer and program development head for the Tesla Semi. Imagine if a Semi could be built in just a few minutes instead of several months. Sounds like a joke, right? But the new production line at Tesla's latest factory can actually make that happen, and ultimately Tesla will be capable of producing millions of semi-trucks.
Well, not only does it not defy physics, we're going to be making a lot of them. So we're going to make I think ultimately we'll make over millions probably, of the Tesla Semi. This is really going to be something that you'll see all over the place, and it'll also be autonomous, or have the ability to go autonomous down the road.
All right, so how exactly will Tesla make the semi-truck more efficient and affordable? What's so special about its new big rig production line? Let's dive in and find out. Okay, from day one, Tesla made it clear the Semi wasn't just another truck. It's a highway monster that can rocket from 0 to 60 miles per hour in only 20 seconds. That's why Tesla's chief designer, Franz von Holzhausen, looked to Japan's fastest train, the legendary Shinkansen, for design inspiration. And now, with these new aerodynamic upgrades, the Semi is feeling more and more like the bullet train of the trucking world. Of course, not everyone's a fan of its design, and that's okay. If you're one of them, drop a comment and tell us what you think. We actually read everyone. Now let's get into some smaller performance tweaks and, more importantly, a brand new battery setup that's coming to the Tesla Semi. According to Tesla's Master Plan Part 3, the long-range Semi, packing an 800 kilowatt-hour battery, currently uses high-nickel cells, most likely NMC chemistry, to hit that impressive range. The short-range version, known as the Semi-Lite, runs on LFP cells instead. But the real game-changer? Tesla plans to power upcoming semi-trucks with its most advanced battery yet, the HV battery, or 4680 cell. HV battery stands for high voltage battery, and in this case, it's all about the 4680 cell. This powerhouse packs up to 300 watt-hours per kilogram of energy density while cutting production costs, thanks to its breakthrough structural design. Even though Dan Priestley confirmed that the upcoming Semi Gen 2 will come with a smaller battery pack, that doesn't mean any loss in range or performance. In fact, the truck keeps its impressive driving distance, boosted by a 7% efficiency gain from improved aerodynamics we mentioned earlier. A smaller, more affordable pack also means less weight and lower operating costs, a win-win for both Tesla and its customers. We've long predicted that the Tesla Semi would make the switch to the 4680 battery, and it just makes sense. Why reserve Tesla's most advanced battery for the Cybertruck alone? The 4680 delivers outstanding power, efficiency, and cost-effectiveness. Exactly what a Class 8 truck needs. Plus, with Tesla producing these cells right at the Nevada Gigafactory, building and integrating battery packs for the Semi becomes faster, simpler, and more efficient than ever. As in the image of the upgraded and changed parts, Dan Priestley also mentioned design improvements such as new rear-view mirrors for better visibility and more aerodynamics. In addition, the Tesla Semi also has drop glass added. Right now, Tesla Semi prototypes come equipped with traditional side mirrors. Each mirror houses 3 integrated cameras, working together with a camera monitor system that streams live footage to a pair of 15-inch displays inside the cabin. This setup not only satisfies US regulations but also boosts aerodynamics and gives drivers a full 360-degree view, no blind spots. What's still up in the air, though, is what Tesla's planning for the Gen 2 mirrors. They might pack in even more cameras, totally possible. Or, as Dan Priestley hinted, the new design could make the Semi even more aerodynamic while enhancing visibility. That could mean smaller physical mirrors paired with smarter, more advanced camera tech. Personally, we're hoping Tesla keeps some form of physical mirrors. They just make sense for a truck like this. What do you think? Drop your prediction in the comments. One new feature we do know about is the addition of drop glass. Now, if you're wondering what that even means, you're not alone. Essentially, the driver's seat in the Tesla Semi is centered, and the cameras do a great job minimizing blind spots. But here's the catch: when drivers need to interact with things like gates or checkpoints, It's not exactly convenient to open the entire cabin door just to talk to someone or hand over documents. The new drop glass, likely a lowerable side window, should solve that problem and make real-world trucking a lot smoother. In the past few years, many, though not all, of Tesla's refreshed models have rolled out with a sleek new light bar, a distinctive design cue that Elon Musk seems to be turning into a brand signature. According to a report from Next Big Future, the Tesla Semi's latest update features redesigned headlights with a modern LED light bar, a potential sleeper cab for long-haul comfort, and improved aerodynamics boasting a drag coefficient of 0.36, about 30% better than diesel trucks. It also packs a tri-motor powertrain delivering a 7% boost in efficiency. The updated headlights could give the Semi a more distinctive look compared to earlier prototypes. Naturally, the light bar itself wouldn't serve as the main headlights. Those will likely sit just below it, handling the actual road illumination. From our view, the refreshed design definitely feels modern and perfectly aligned with Tesla's current design language. What about you? Would you like to see the Semi rocking this new look? Drop your thoughts in the comments below. In addition, Tesla's plan to add a sleeper cab to the Semi isn't just a rumor anymore. It's happening. We'd confidently bet on it. Why? Because Dan Priestley himself mentioned it some time ago. We remember it clearly. Around last year, he said the Semi would eventually come with a sleeper cab, giving drivers the ability to rest comfortably during multi-day long-haul trips. Honestly, this might be the most exciting update yet for the next-gen Semi. Sleep is a huge deal for truckers. Fatigue is one of the top causes of trucking accidents on cross-country routes that stretch for thousands of miles. The current Semi doesn't have a dedicated sleeping area, even though the cabin is spacious enough to suggest the potential. That's understandable for early prototypes focused on testing, but once full production ramps up, a sleeper cab will be practically essential. What's still unclear is how Tesla will implement it. Will they extend the cabin backward or reconfigure the interior to make space within the existing layout? Hard to say for now, but either way, it's an exciting step forward. Next Big Future also reported that the updated Semi will feature improved aerodynamics with a lower drag coefficient. The current prototype sits at about 0.40, but with tweaks to the glass and mirrors, that number could drop to 0.36. Okay, that's a big deal. Smoother airflow means better acceleration and improved energy efficiency, helping the Semi push even further ahead of traditional diesel trucks. As we've pointed out before, the Tesla Semi's electric motor and battery system are far simpler than the intricate diesel engines found in conventional trucks. This streamlined design drastically reduces the number of moving parts and cuts down assembly time, making large-scale production far more feasible. Elon Musk has mentioned a long-term goal of producing 50,000 units per year, and while that's unlikely to happen next year, it's not unrealistic in the near future. Based on current progress, we estimate Tesla could reach around 20,000 Semis in 2026, an ambitious yet attainable figure, especially since the new production line is expected to kick off by the end of this year. Another major upgrade for the Semi Gen 2 will be the introduction of supervised full self-driving. Now you might think, there's no way a massive truck can safely drive itself on public roads, but Tesla is seriously planning to debut it with the 2026 model. This move fits squarely into Tesla's broader mission to modernize freight logistics and make truck driving more accessible. From our perspective, this isn't just another software update, it's a transformative leap forward that could redefine the entire heavy-duty transport sector. Why? Because FSD on the Semi Gen 2 could allow the truck to operate for far longer stretches without constant driver input. That means reduced fatigue, fewer health risks, and dramatically improved supply chain efficiency, something logistics companies have been chasing for decades. Of course, the key term here is supervised. The driver will still be in the cabin monitoring the system, but won't need to keep their hands on the wheel for most of the journey. Tesla's advanced sensor suite and AI processing enable the Semi to interpret massive amounts of real-time data, letting it safely handle everything from busy interstates to tight loading docks. Still, it's impossible to ignore the challenges. Rolling out FSD in an 80,000-pound truck is bound to raise eyebrows, not just from regulators but from the public and driver unions as well. Any mishap, even a minor one, could ignite controversy and bring up tough questions about the safety and accountability of AI-driven transport. And beyond that, there's the long-term question of jobs. If Tesla ever transitions to unsupervised autonomy, it could reshape, or even shrink, parts of the long-haul trucking workforce. Legal experts also point out that any accident involving an autonomous Semi could spark complicated liability disputes, shifting responsibility away from the driver and directly onto Tesla as both manufacturer and software provider. For all these reasons, the Tesla Semi Gen 2 with full self-driving stands as both a bold leap forward and a high-stakes gamble. Its success will ultimately depend on two key factors. First, Tesla's ability to prove that its system is safer than a human driver. And second, how effectively the company collaborates with regulators to create a clear and reliable legal framework. If Elon Musk and his team can pull it off, the Semi Gen 2 won't just be another truck. It could become an icon of the autonomous transport era, ushering in a future where goods move around the clock with near-flawless precision. But if things go wrong, it could spark a serious backlash, making the entire industry more cautious or even hesitant to chase the dream of fully autonomous freight. Now, looking ahead, we expect the Tesla Semi Gen 2 to carry a higher price tag than the first generation model, and honestly, that makes perfect sense given the scale of improvements on the table. Every major technological leap comes at a cost. Between FSD integration, aerodynamic enhancements, and the addition of Tesla's advanced 4680 battery, production expenses are bound to rise. Still, Tesla has a proven track record of driving down costs through volume production and efficiency gains. Just as we saw with the Model 3 and Model Y, where prices initially climbed after big upgrades and later dropped once manufacturing matured, the same playbook could apply here. Expect a slight price bump at launch to reflect the added value, followed by gradual reductions as Tesla scales production. And frankly, the potential price increase would be more than justified. FSD alone could completely redefine the total cost of ownership. A Semi that can operate almost continuously means less downtime, fewer accidents, optimized logistics, and higher productivity. Combine that with the efficiency and longevity of the 4680 battery, which cuts both maintenance and energy costs, and the Semi Gen 2 could end up being far cheaper to operate over time than any diesel truck on the road today. Over the years, the Tesla Semi has consistently been seen as Elon Musk's most challenging project. Fewer than 1,000 Semis have hit the road so far. Unlike the Model Y, Model 3, or Cybertruck, this massive electric truck has never had a dedicated automated production line. Most current Semi units are still assembled by hand, relying heavily on manual labor and semi-automated processes. This results in slow production speeds, high costs, and low efficiency. Last month, drone footage from Giga, Nevada captured a massive press machine, weighing tens of tons, being transported from Giga, Texas to Giga, Nevada, using 2 tractor units and 3 oversized trailers. This quietly revealed that Tesla is preparing to deploy the Giga Press for semi-production, marking a major milestone in the history of electric truck manufacturing. The Giga Press has turned Tesla into a symbol of modern manufacturing. It's a giant die-casting machine capable of producing massive one-piece aluminum alloy chassis components in a single press. In the past, automakers had to weld, bolt, or glue together hundreds of smaller parts to form a car's frame, a process that was time-consuming and weakened the structural integrity. With the Giga Press, that entire process is reduced to just a few minutes. Its efficiency is so revolutionary that Elon Musk once said, "You can't understand Tesla if you don't understand the Giga Press." However, applying this technology to the Tesla Semi is no simple task. The Semi is a heavy-duty truck, several times larger and heavier than a Model Y or Cybertruck. Its frame must support loads of tens of tons, operate continuously in harsh environments, and still maintain exceptional durability. Tesla's existing Giga Press machines, which exert between 6,200 and 9,100 tons of clamping force, are optimized for passenger vehicles and pickups, and aren't large enough to cast the enormous components needed for the Semi. As a result, for years Tesla has had to rely on traditional manufacturing methods, stamping, welding, and assembling parts piece by piece. Now, with the arrival of a special Giga Press designed specifically for the Semi, everything has changed. This could be the largest die-casting machine Tesla has ever used, engineered to produce the Semi's main structural components in a single casting cycle. It opens up the possibility of achieving a production rate of 1 Semi every 20 minutes, a figure Elon Musk once described as essential to reaching the goal of 50,000 units per year by 2026. If realized, this would solve Tesla's biggest long-standing challenge: production scale. The Giga Press doesn't just speed up manufacturing, it also drastically reduces costs and assembly errors. Each one-piece cast component is incredibly precise, saving materials, cutting vehicle weight, and improving aerodynamic efficiency, all critical factors for an electric truck. The integrated casting process also makes the Semi more rigid, reduces vibration under heavy loads, and simplifies maintenance and repair. More importantly, Tesla's investment in a Giga Press for the Semi marks a major step forward in heavy industrial manufacturing. If the Model Y was said to have revolutionized the car industry, then the Semi could revolutionize the trucking industry. No manufacturer, not even giants like Daimler or Volvo, has ever applied large-scale die casting to heavy-duty trucks before. With its new 4 million square foot facility at Giga, Nevada, Tesla now has not only the space to operate this massive press, but also the infrastructure to establish the first fully automated production line dedicated to the Semi. This is the missing piece that Tesla has long awaited. And once it's in place, the prospect of producing tens of thousands of Semis per year will no longer be a distant dream. The impact of this breakthrough will extend far beyond a single factory. With the Giga Press, Tesla can cut frame production time from hours down to just minutes, eliminate hundreds of assembly steps, and ensure consistent quality across every unit. As production speed rises and costs fall, Tesla will be able to lower prices, making the Semi far more competitive for transport companies where every dollar spent on fuel and maintenance matters. From a technical standpoint, the Semi has already proven its unrivaled status in the electric truck segment. A 500-mile range, 0 to 60 miles per hour acceleration in just 20 seconds, energy consumption of only about 1.7 kilowatt hours per mile, and the ability to charge up to 80% in just 30 minutes. When paired with Tesla's next-generation 4680 battery cells, lighter, cheaper, and with higher energy density, the Semi Gen 2 will not only be more powerful, but also significantly more efficient. If everything goes according to plan, 2026 could mark the year Tesla enters the era of mass-producing the Semi, a historic milestone for the global transportation industry. Imagine a world where massive electric truck fleets operate around the clock, moving goods more safely, more affordably, and without emission. Every Semi on the road would replace a traditional diesel truck, cutting tens of tons of emissions each year, a powerful step forward for both the economy and the environment. Okay, how do you feel about a world with zero-emission trucking? Do you think the price of the Semi will drop once mass production begins? The two most controversial Tesla vehicles, the Cybertruck and the Cybercab, are back in the spotlight following some noteworthy new developments after the recent Q3 earnings call. We know a lot of people dislike these two models because each is outlandish in its own way, leading most users to be skeptical and ask questions. While the Cybercab robotaxi has been given an official production date by Elon Musk after a long testing period, the Cybertruck is facing a bothersome defect that led to a recall. 63,000 Cybertrucks have reportedly been recalled, a number that is nearly the total volume sold so far, marking the 8th recall for the vehicle. The underwhelming sales figures have sparked various theories that Tesla might be discontinuing the Cybertruck soon. Meanwhile, Tesla's new $30,000 affordable car is also gaining public interest. This is the current situation with Tesla's vehicle models. Is Elon Musk headed in the right direction with them?
Like the single biggest expansion in production will be the Cybercab, which starts production in Q2 next year. That's really a vehicle that's optimized for full autonomy. It, in fact, does not have a steering wheel or pedals.
Following the recent Q3 earnings call, Elon Musk and the Tesla leadership team have sent shockwaves through the investment and technology communities by announcing a series of game-changing updates on several of the company's products. One of these is the Cybercab, Tesla's first robotaxi model, which is seen as the final component in the leading EV manufacturer's ambition for driverless transportation. Although the Cybercab was unveiled last October, it lacked a mass production line. The vehicle will not be manufactured on a conventional assembly line, but on a completely new process called the Unbox production line. According to Elon Musk, this line is nearly complete, and he announced that mass production of the Cybercab will commence in the second quarter of 2026. Tesla is currently recruiting hundreds of Cybercab body production engineers and technicians, a clear sign that the company has entered the actual manufacturing phase. Previously, many people had hoped the production version of the Tesla Cybercab would feature a steering wheel and pedals, but Elon Musk once again confirmed that the production version will have neither. It's genuinely a vehicle optimized for full autonomy. In fact, it has no steering wheel or pedals, and is truly a long-term optimization to minimize the cost per mile, allowing for a comprehensive calculation of the total operating cost per mile. Elon Musk asserted that Tesla has completely solved the challenge of high-level full self-driving and that he is 100% confident the technology is at least as safe as, or even superior to, human driving. This is Musk's boldest declaration in years, signaling the moment Tesla is ready to move into the practical deployment phase of autonomous taxis by the end of next year, once Tesla has a large Cybercab network established. The compact size and sleek profile of the Cybercab are optimized for urban environments. The two-seater design ensures maximum comfort and ample luggage space, while maintaining a lightweight and energy efficiency. The interior materials are durable and easy to clean, which is ideal for high-use taxi fleets. A panoramic glass roof enhances the feeling of spaciousness, compensating for the lack of a rear window. Inside, passengers can access the Tesla infotainment ecosystem, including streaming services, navigation, and automatic trip updates. Each ride is customized. The vehicle automatically adjusts the temperature, lighting, and seat position based on user preferences stored in the Tesla app. The current version, FSD version 13, has achieved an astonishing level of naturalness. The car can detect and react to complex human-like situations, such as slightly slowing down upon seeing an animal on the side of the road or adjusting its position to avoid an obstruction. Coming soon, Tesla will launch FSD version 14, which includes reasoning capability, a major leap forward that helps the AI understand context and make decisions like a real human. Musk is confident that the system is safe enough to allow passengers to sleep, work, or use their phones while the vehicle is in motion, though he emphasized that fully unsupervised driving deployment will occur before users are permitted to sleep in the car. With the latest announcement during the call, Elon Musk stated that Tesla will begin operating autonomous taxis without a safety supervisor in certain areas of Austin, Texas before the end of 2025. The Tesla CEO said that this is not just a technical milestone, but a safety-focused transformation. Fully autonomous, with nobody in the car, is actually safer. Because when you put a human in the car who is not paying attention, the risk is higher. Tesla also confirmed they will expand robotaxi operations to 8 to 10 major metropolitan areas in the U.S. during the same period, including Nevada, Florida, and Arizona. This indicates that the company is deploying a cautious yet decisive strategy, testing in limited scope, optimizing data, and then scaling up nationwide. Okay, the Cybercab is being produced at a cost of around $30,000, but it's not simply a new vehicle model. It's an autonomous mobility service business model that Elon Musk has nurtured for many years. The truth is, many other vehicle models were delayed because of this car. Any Tesla vehicle equipped with FSD can operate as a taxi when not in use by its owner, generating passive income for the owner while helping Tesla transform millions of cars into a massive autonomous transportation network. Although any Tesla car can join the robotaxi fleet, the Cybercab is considered the model specifically optimized for the robotaxi service, featuring no steering wheel and no pedals, operated entirely by AI. This will be the first vehicle in Tesla's history to be designed driverless from the start. Hopefully, the increasing sophistication of the FSD system and the Cybercab production line will not encounter any further unforeseen challenges. Meanwhile, Tesla is currently recalling over 63,000 Cybertrucks in the United States because their front lights are too bright, which could distract other drivers and increase the risk of a crash. The National Highway Traffic Safety Administration stated that this recall includes certain Cybertrucks from the 2024 through 2026 model years. In the recall report, Tesla estimated that 100% of the 63,619 affected vehicles have this defect. The vehicle's software can cause the front parking lights to be excessively bright, distracting oncoming drivers and increasing the risk of a collision. Fortunately, there have been no accidents or injuries reported in connection with the Cybertruck defect. The issue was discovered during an internal review when Tesla engineers found that the lights were brighter than the maximum allowed by federal regulations. These lights exceeded the maximum luminous output and did not comply with federal safety standards. To remedy the problem, Tesla stated that they have released a free over-the-air software update instead of having to perform complex and costly hardware replacements. Through this incident, we also learned the approximate number of trucks sold to date. Although this recall is not a critical incident, since Tesla can fix these kinds of issues with just a few lines of code, it did reveal some data that was previously unavailable to us. The NHTSA is required to specify the number of vehicles affected by a recall, which in this case includes 63,619 vehicles. While technically this number may not account for every single Cybertruck ever sold, it is likely quite close to the total volume delivered so far. As we all know, Tesla does not report Cybertruck sales as a standalone model, instead bundling it under the other models category along with the Model S and Model X, forcing news agencies to rely on registration numbers and other data for estimated figures. This number, 63,619, is the clearest indication we have of how many vehicles Tesla has sold since the Cybertruck launched in late 2023. This is an interesting number, considering that at one point Tesla claimed to have over 1 million pre-orders and suggested it could sell 250,000 units annually. Of course, that was when the expected starting price was around $40,000. Looking at the Tesla website now, the cheapest Cybertruck costs $80,000, which is a significant difference. Elon Musk once invested a great deal of effort into this model, but the controversy surrounding it has not yet ceased. The Cybertruck is even ineligible for operation in many European countries due to the pedestrian safety risk posed by its design. Not just the Cybertruck, Tesla has also issued a recall for 12,963 Model 3 and Model Y vehicles, according to documents filed with the National Highway Traffic Safety Administration. The reason for the recall is that they may suddenly lose propulsion while driving. Approximately 40% of the recalled vehicles are Model 3, all from the 2025 model year. The remaining 60% are Model Y SUVs, all from the 2026 model year. Specifically, these vehicles are equipped with a battery pack contactor made with an Inteika solenoid. The battery pack contactors may fail without warning. If the contactor opens while the vehicle is being driven, the driver may not be able to accelerate, which could cause a loss of power and increase the risk of a crash. However, once there is a loss of power, a visual alert will appear on the screen instructing the driver to pull over. Typically, Tesla addresses recalls via over-the-air software updates, like the Cybertruck Lite issue. However, this time, drivers will have to bring their Model 3 and Model Y vehicles to a service center for direct replacement of the faulty contactors. The repair will be completely free of charge. Besides the Cybercab, another project mentioned quite frequently is Optimus, which could be considered the central focus of the earnings call. Musk stated that Optimus version 3 will be unveiled in the first quarter of 2026 and could look so lifelike that you have to touch its skin to believe it's a robot. Currently, Optimus 2.5 is already operating in Tesla's factories, capable of guiding visitors and performing basic tasks. However, version 3 is designed for mass production, with the goal of reaching a production run rate of 1 million units per year by the end of 2026, and eventually advancing to 10 million units per year with Optimus version 4. Although these figures are still a long way off, analysts suggest that Tesla has achieved significant technological progress. The biggest challenge for humanoids today, hand dexterity, is what Tesla is now focusing on solving. When that happens, the Cybercab and Optimus will become two parallel icons of the AI embodiment era. If the Cybercab is a robot on wheels, the Optimus is a bipedal humanoid robot. Both products are what Elon Musk is betting on as a huge gamble for Tesla. However, during the Q3 earnings call, what Elon Musk failed to mention and somewhat avoided was the rumored low-cost vehicle, speculated to be priced under $30,000 and to be built on the same platform as the Cybercab, as well as a more conventional SUV model based on the Cybertruck platform. This is quite strange, as the question about these two models was the second most upvoted question prior to the meeting, but it was not addressed during the call. In March 2024, Tesla had announced the abandonment of its plan to develop the next-generation compact electric vehicle, which people referred to as the Model 2, a project that was once expected to greatly expand the company's market. Instead, Tesla chose a safer route, launching stripped-down versions of the Model 3 and Model Y. However, as these efforts are proving less effective, the American automaker is being forced to reconsider its strategy of developing an entirely new, smaller, and more affordable EV model. In China, the world's most dynamic EV market, rumors about Tesla's compact car have resurfaced. The reason is that the reduced-spec versions of the Model 3/Y have failed to make an impression and are even considered unremarkable among the multitude of domestic competitors. Tesla was prepared for the potential failure of this strategy. The Model 3 Standard and Model Y Standard were marketed as solutions to make Tesla technology accessible to more customers while leveraging existing production capacity. However, the reality shows that user feedback has been quite negative. They argue that Tesla cut too many features, while the price point was not appealing enough to compensate for those losses. Before the streamlining plan was implemented, Tesla was expected to launch a compact, mass-market electric vehicle based on an entirely new third-generation EV architecture. The revolutionary manufacturing process, dubbed the unboxed process, promised significant cost reduction, potentially allowing Tesla to sell the car for under $25,000. However, in early 2024, Elon Musk abruptly changed course. The reasons cited were disappointing sales figures coupled with the belief that full self-driving technology was on the verge of a breakthrough. With dwindling demand and untapped production capacity, Musk determined that releasing cheaper variants of the Model 3 and Model Y was the fastest way to fill the production lines. Nevertheless, temporarily shelving the next-generation EV line is seen as a strategic mistake. This decision not only cost Tesla its pioneering advantage in the EV market, but also caused the company to gradually fall behind in the race for the mass-market segment, where Chinese and European rivals are rapidly gaining ground. As far as we know, two projects codenamed NV91 and NV93 are reportedly set to give birth to two entirely new electric vehicle models, with a retail price of under $25,000, in line with the commitment Elon Musk made at the 2023 Investor Day event. This is seen as Tesla's effort to realize the vision of EVs for everyone, while restoring its competitive edge as Chinese rivals lead the low-cost battle. According to observers, the new generation NV91 and 93 series will play a crucial role in Tesla's cost reduction strategy, thanks to the application of the third-generation EV platform and the breakthrough unboxed process. If this information is accurate, it implicitly acknowledges a reality. Tesla no longer holds high expectations for the simplified Model 3/Y versions, especially in the Chinese market, where consumers are increasingly difficult to convince with feature-cut versions whose prices are not soft enough. For years, Tesla fans, budget-conscious customers, and investors alike have held on to the hope for an electric vehicle that carries the brand's technological hallmark but is priced competitively with gasoline cars. They looked forward to a compact, modern, self-driving Tesla that was more accessible than ever before. Yet, after nearly half a decade of waiting, all customers received were the Model 3 Standard and Model Y Standard, simplified versions with a starting price of around $39,000. To achieve this price point, Tesla was forced to remove a range of features once considered iconic to the brand, which disappointed quite a few people. These versions lack enhanced autopilot, heated rear seats, ambient interior lighting, power-adjustable seats, and even the front trunk has been downgraded. Some basic features like direct tire pressure monitoring were also replaced with an indirect system, forcing the driver to check manually. A regrettable step backward for a brand regarded as a pioneer in automation. These changes are more than just cost-cutting measures. They reflect a dilution of the core Tesla experience, the very thing that once made customers willing to pay a premium. More importantly, they expose an undeniable reality. Tesla cannot reach the $25,000 target simply by stripping down an existing platform without losing its identity. To build a truly cheaper EV, Tesla will need to develop an entirely new platform, optimized from design to production, a move that requires a massive investment in new assembly lines and technology. However, with raw material costs remaining high, even with battery prices having dropped, the dream of a $25,000 Tesla is becoming more distant than ever. For Tesla's loyal fanbase, including owners, investors, and the EV enthusiast community, the company's current pivot is truly disappointing. The $25,000 EV was once seen as the symbol of democratizing technology, an opportunity for Tesla to bring its magic to the masses without sacrificing the premium feel, performance, and autonomy that are the brand's DNA. Yet, instead of fulfilling that dream, the standard versions of the Model 3 and Model Y deliver a sense of subtle yet profound betrayal. The price is still high relative to the perceived value, while being too expensive for the customer segment they were intended for. Even the Cybercab project, we believe, makes many people feel alienated. While it is an efficient, economical, and exciting public transport vehicle, it will simultaneously be unsuitable for those who cherish the driving experience, customization, and the joy of ownership, the values that once defined the Tesla community. Okay, would you feel safe getting into a fully autonomous Tesla with no human driver inside? Do you think Cybercab will replace Uber and Lyft in the next few years? Let us know in the comments below. Throughout his career, Elon Musk has repeatedly stunned the world with ideas that once seemed crazy, but ultimately turned into reality. From turning EVs into a global trend, building a worldwide charging network, to reusing rockets with SpaceX, something that once only existed in science fiction, all of it proves one thing. Elon Musk is a visionary whose foresight goes far beyond what most people consider realistic.
It will be an age of abundance, the likes of which people have not, almost no one has envisioned. It will be something special.
However, there's one ambition that Musk has mentioned not once but twice, and each time it sent shockwaves through the tech world as this could be the ultimate game changer and Tesla's most profitable product yet. Yeah, Elon Musk has twice brought up the Tesla flying car project, and most recently, the Tesla CEO hinted that it could actually arrive as soon as 2026. Okay, not a spaceship, not a supercar, but an everyday vehicle that, instead of just driving on city streets, would hover above them powered by Tesla's advanced motors. What truly has everyone on edge, though, is its rumored price tag, something so outrageous it almost sounds impossible. We all know Musk is famous for dropping jaw-dropping price points for new products, and the Tesla flying car could come in under $10,000, specifically at $6,789. An unbelievably cheap price for such futuristic tech. But you know, a special production line may be the secret behind this number. So why did Elon Musk choose that price? And if the flying car becomes reality, how will it disrupt the auto industry? Will special licenses be required to operate one? As we all know, Elon Musk is never one to sit still. Whenever competitors, especially Chinese companies, release products that could threaten Tesla's position, he always finds a way to go further and bolder. And surprisingly, Musk has twice revealed an idea that almost no one thought he would ever seriously pursue: developing an electric flying car. It would feature two modes, functioning like a regular car and in less than 2 minutes transforming into a mini aircraft. Back in 2014, when Tesla had only produced two models, the Roadster and the Model S, Elon Musk made headlines by saying, "Maybe we'll make a flying car." Yeah, most people believed it was just a joke from the CEO, since at that time flying cars existed only in science fiction movies. However, the concept has long since broken free from fiction, with numerous prototypes already brought into the real world, such as Klein Vision, Leo Flight, Vertical Aerospace, Terrafugia, and many other ambitious startups. Musk's most recent statement about the Tesla flying car, however, is even more important. It gives us the clearest glimpse yet of what Tesla's flying car might actually look like. However, at the very least, there's no need to argue about the concept of a flying car anymore, since all the models from those manufacturers already exist in the real world. And the Tesla flying car will be the next product to spark heated debates, both positive and negative. Most people would be excited about a car that can soar through the skies, offering faster, longer, and more cost-efficient travel. On the other hand, some worry about the risks of such a vehicle. Clearly, it's far more dangerous than driving a regular car on the road. Once an accident happens, the chances of survival are very slim. Elon Musk must prove that the Tesla flying car isn't just a bold idea, but a machine that is absolutely safe, meeting the strictest technical standards and reducing the risk of accidents to nearly zero. At the same time, all flying cars today require a special pilot's license. So the Tesla flying car would be no exception. This is exactly why Giga Texas has been chosen as the hub for developing the flying car prototype. Among Tesla's 5 factories, this facility not only has the most advanced and flexible production lines, but also brings together a highly experienced team of engineers who have already proven their expertise in a series of critical projects. Giga Texas has also been positioned by Elon Musk as the heart of Tesla's technology, previously serving as the launch site for the company's full self-driving system, a technology that demands near-perfect levels of safety and reliability in the EV industry. According to insiders familiar with the project, the Tesla flying car will inherit and reuse certain platforms from the Model S and the Roadster, two vehicles considered the performance pinnacles in Tesla's history. This suggests that the flying car won't merely be an experimental step forward, but rather a fusion of proven technology and groundbreaking innovations. Currently, the flying cars attracting the most attention on the market are likely the Leo Coupe from Leo Flight Corporation and the Air Car from Klein Vision. The reason is simple. While many other flying car projects remain at the concept or prototype stage, these two manufacturers have already made major breakthroughs with their flying car products. Some sources reveal that Tesla has quietly partnered with Leo Flight Corporation to learn from their engineering expertise and apply it to the Tesla flying car. Elon Musk is rumored to have held several secret meetings with the company's CEO. This opens up the possibility that the Tesla flying car will be inspired by and integrated with many of the technologies found in the Leo Coupe. Leo Flight Corporation, an aerospace technology company based in Indiana, USA, is making waves in the field of personal air mobility. Instead of following the path of traditional flying car makers, Leo boldly refers to its creation as a supercar in the sky, fully electric, futuristic in design, powered by an advanced electric jet propulsion system, and redefining the very concept of urban transportation in the 21st century. At the heart of this vision is the Leo Coupe. Measuring just 10 feet wide and 20 feet long, this compact eVTOL is small enough to fit inside the garage of a modern home, or even be placed on the rooftop of a high-rise building. Inside, the cockpit feels like a miniature spacecraft. Panoramic windows all around, a transparent floor offering views of the city below, sporty seating, and a sleek digital dashboard. It's not just a means of transportation, but a deeply futuristic personal experience. What truly sets the Leo Coupe apart is its philosophy of absolute safety. The aircraft is equipped with a full-body parachute system, a technology already proven in light aviation, along with landing gear that can deploy into cat's paw pads filled with compressed air, designed to absorb impact forces in emergency situations. This is an innovative solution that virtually no other commercial eVTOL currently offers. On the technology side, the Leo Coupe is expected to feature a rare boxwing design combined with over 200 small electric jet engines. Each engine measures just 11 centimeters in diameter, yet generates up to 11.7 pounds of thrust. Altogether, the system delivers more than 2,300 pounds of thrust, while the aircraft's empty weight is only about 1,100 pounds, enough to carry an additional 510 pounds of passengers and cargo, roughly equivalent to a small car. The use of multiple small engines brings a host of strategic advantages. Quick maintenance replacements can be done in just minutes, lighter wiring that reduces overall weight, and compact ESC controllers that improve stability while lowering the risk of overheating. More importantly, thrust is evenly distributed across the aircraft's body, enhancing balance and providing greater redundancy in case of failure, a safety benchmark that most other eVTOLs have yet to achieve. In terms of performance, each engine consumes only 1.7 kilowatts. The entire vertical lift system peaks at just 340 kilowatts, while cruise flight requires only about 54 kilowatts, enabling 75 minutes of flight at a cruising speed of 240 miles per hour. Even more impressive, the Leo Coupe reaches a top speed of 248 miles per hour and a range of 298 miles, far surpassing most current eVTOLs, which typically achieve only 93 to 168 miles. This means the Leo Coupe isn't just competitive for urban mobility, but could realistically replace high-speed trains or small business jets on short intercity routes. Notably, instead of using large, noisy, and hazardous rotors, the Leo Coupe employs electric jet fans integrated into the body, significantly reducing noise and making it more suitable for densely populated urban environments. Leo Flight doesn't stop there. The company is also planning a single-seat version, the Leo Solo, which complies with FAA Part 103, allowing it to be flown without a formal pilot's license, paving the way for eVTOLs to become truly mainstream. Accompanying this is the VertiStop ecosystem, compact landing pads that double as charging stations, supporting the future network of urban air mobility. As for pricing, the starting figure was initially expected to be under $290,000, but due to post-COVID supply chain impacts, it has now risen to $459,900. However, considering its 248 miles per hour top speed, nearly 300-mile range, safe and easy-to-maintain electric jet engines, and uniquely futuristic experience, this price fully reflects the caliber of a supercar in the sky. That's the Leo Coupe flying car. Coming back to Elon Musk's latest mention of a flying car, he shared a simulation video of a Cybertruck soaring through the skies above a city and wrote, "Maybe Tesla should make this." This subtly hints that Tesla's flying car design could end up resembling what appeared in that video. In our view, the biggest difference between the Tesla flying car and existing aerial vehicles lies in Tesla's choice to go fully electric rather than rely on traditional combustion engines. This is a bold and pioneering move that brings both opportunities and challenges. With this decision, Tesla not only reinforces its commitment to sustainability within its global energy strategy, but also significantly reduces the environmental impact of personal air travel, continuing the legacy of success. It is built with electric cars. The shift to electric power brings clear advantages: lower greenhouse gas emissions, reduced noise, two inherent weaknesses of combustion engine aircraft that have yet to be fully resolved. Moreover, Tesla holds a major advantage in battery technology, which serves as the heart of its entire product ecosystem. This will provide a critical foundation for creating a flying car that is eco-friendly, cost-efficient to operate, and capable of delivering a smooth, seamless journey for users. However, the technological challenge is no small matter. The battery must strike a perfect balance between capacity and weight, a critical factor in aviation. A high-capacity but overly heavy battery would reduce lift and limit range. On the other hand, a lightweight battery with low capacity would not provide enough energy for long or stable flights. This is the hard problem that every eVTOL manufacturer has to face, and the key question is, how will Tesla optimize its battery technology to maintain flight performance while keeping weight within the ideal range? The answer likely lies in the 4680 battery, the next-generation cell Tesla has developed. With an energy density of up to 300 watt-hours per kilogram, the 4680 can store more energy without adding extra mass. This allows Tesla to power its flying car with abundant energy while avoiding the downsides of bulky or excessively heavy packs. At the same time, the 4680 is designed to reduce production costs, helping Tesla realize its goal of building a flying car that is affordable, lightweight, powerful, and capable of longer ranges than most eVTOLs on the market today. Although Tesla has yet to reveal an official design, based on Elon Musk's suggestive tweet, it's highly likely that the Tesla flying car will draw inspiration from the Cybertruck. The body is expected to retain the distinctive DNA of the Tesla Cybertruck, angular, sharp-edged, and clad in a metallic silver shell that conveys strength and durability. This design choice makes sense, as the Cybertruck was originally built with an ultra-strong exoskeleton frame capable of withstanding extreme pressure, an attribute well-suited for meeting aviation safety requirements, even if it adds a bit of extra weight. The most striking feature would be the inclusion of foldable wings and dual jet engines mounted on each side, evoking imagery of fighter jets or spacecraft, an ambition Elon Musk has consistently pursued with SpaceX. This design not only generates lift, but also ensures vertical takeoff and landing capability, a crucial requirement for operating flying cars within dense urban environments. The wings are designed with an aerodynamic folding mechanism, allowing them to retract when driving on roads and extend when flying, similar to the systems used in modern fighter jets. If realized, this would give the vehicle seamless flexibility for both urban environments and highways. Inside, the cockpit retains Tesla's signature minimalist style, but adds a panoramic windshield and a digital control panel. The biggest leap, however, would be the integration of a 3D autonomous flight AI system, not only handling ground navigation, but also managing flight paths, altitude, and mid-air collision avoidance. This is where Tesla's autopilot and full self-driving technologies could evolve to an entirely new level. We predict that with advanced aerodynamics and optimized weight balance, the Tesla flying car could achieve breathtaking performance, accelerating from 0 to 60 miles per hour in just 1 second, while maintaining a stable cruising speed of around 200 miles per hour. That said, developing a flying car is far from as simple as just adding wings to a Tesla EV. It represents a massive leap in both technology and design, requiring solutions to challenges never before faced. Aerodynamics play a central role. In the air, stability and flight control are exponentially more critical than on the ground. On top of that, Tesla must meet the rigorous aviation safety and certification standards, which are far stricter than those applied to automobiles. Much like the story of full self-driving, earning regulatory approval will demand a long process of testing and evaluation. This means that everything from the chassis design and material structure to the flight control software must undergo a series of rigorous tests to guarantee safety and optimal performance in three-dimensional space. A frame that isn't durable enough could degrade quickly after repeated flights. Control software that isn't responsive enough could destabilize the vehicle during transitions. This is why Tesla has chosen a different path: electric jet propulsion, technology inspired by SpaceX, but specially engineered for electric aircraft. This solution not only boosts performance but also minimizes noise, delivering a smoother and cleaner flying experience compared to traditional engines. The transition between car mode and flight mode is another technological highlight. On the ground, the Tesla flying car operates like a mini Cybertruck with an aluminum alloy and carbon fiber frame that is both lightweight and durable. Thanks to its powerful electric motors, it can accelerate from 0 to 60 miles per hour in just 1 second, while its integrated self-driving system ensures a safe and convenient road journey. When the user decides to take off, the entire transformation happens with a single button press in under 60 seconds. Multi-jointed wings unfold from the body, the tail extends for added stability, and the wheels fully retract to maximize aerodynamics. The entire system works in perfect synchronization, turning the car into a compact yet powerful aircraft. In flight mode, the Tesla flying car can reach a top speed of 200 miles per hour and a range of up to 700 miles, thanks to the 4680 battery pack, an outstanding figure within the eVTOL segment. Its intelligent landing system allows for safe touchdowns even on uneven surfaces, making Tesla's flying car an ideal solution for dense urban environments where takeoff and landing space is often limited. The fusion of electric vehicle technology, aerodynamic design, and an aviation-grade safety philosophy makes the Tesla flying car more than just another mode of transport. It represents the dawn of an entirely new era of mobility. As ground traffic grows increasingly congested, taking off will no longer be a privilege reserved for pilots, but a practical option for everyday people. And once again, Tesla is striving to turn what was once considered science fiction into reality. China is often seen as a giant in copying technology, drawing from global breakthroughs and turning them into its own achievements. This is precisely why Elon Musk has long envisioned a vehicle unlike anything Tesla currently produces, something that no one can simply replicate. Behind its surprisingly competitive price tag lies what seems like a bold statement to rivals, especially those who copy Tesla's innovations. You may steal Tesla's ideas and technology, but to produce at this price point, China would need decades of effort. Do you believe flying cars will become a common mode of transportation in the next 10 to 20 years? Would you try it right away or wait until the technology matures? If you enjoyed this video, don't forget to like, share, and subscribe. And let us know in the comments, would you dare to fly in a Tesla flying car? See you in the next video.